Welcome to Homework Lib.
Hi, so over here we're told that scatter plots show the relationship between dependent, the response, and independent predictor variables, and in this activity, you will test or understand what these are. So in this case, since there is no appreciable question, I will proceed to describe how scatter plots are going to function. So scatter plots are going to be a mathematical representation of data in which we're going to have a dependent variable and an independent one. So the dependent variable is going to be available on the y-axis, while the independent variable will appear on the x-axis. So over here, what we're going to have usually is going to be a large set of data points, which are usually experimental data points, which are going to allow us to have some prediction of the behavior employing different types of trend lines. So depending on the shape of the scatter plot, we may have different behaviors associated to different physical or mathematical behaviors which are of interest to us. So always whenever we have these scatter plots, we're going to have an associated fit to the data points, in which in general we can say if the data is going to be correlated or not. So the type of correlation can be positive, negative, or null correlation. In both of the examples that I provide over here, the correlation is going to be positive since the trend is to go up. An example of a negative correlation would be a scatter plot where the data looks like this, for which we can write down a trend line in between. As such, this corresponds to negative correlation. And finally, an example for null correlation would be a scatter plot that has no appreciable trend line whatsoever. We have large variation on both of the data sets, so the independent and the dependent variables are said to be uncorrelated. So, in all of the scatter plots, what we're going to be able to have is that the trend lines, if we want to find linear behavior in between the dependent and the independent data, then the trend line is called a linear regression. Otherwise, it is going to be a polynomial fit. And with that, it would be all. For the null correlated values, you're not going to be able to find an appropriate trend line in either approach. And with that, it would be all. Thanks and have a good one.